conversion and racemization. Elimination reactions. Alkyl halides undergo beta elimination of hydrogen and halogen atom to form alkenes on being heated with KOH or KNH2. The reaction is called dehydrohalogenation. Satizhev rule. In most of elimination reactions, more alkylated alkene is the major product. The stability of more alkylated alkene is due to its lower energy. Hyperconjugation effect of alkyl group helps in lowering the energy of the product. Reaction with metals. Haloalkanes react with metals to form corresponding organometallic compounds. The reaction of haloalkanes with magnesium metal in anhydrous ether as solvent results in the formation of alkyl magnesium halides, which are referred more commonly as Grignard reagents. Wurtz reaction. In Wurtz reaction, two alkyl halide molecules are coupled in presence of sodium metal in anhydrous ether to form a new carbon-carbon bond and thus giving a symmetrical alkane. Reactions of haloarenes. Nucleophilic substitution. Aryl halides are very less reactive towards nucleophilic substitution reaction because resonance effect. In haloarenes, CX bond picks up partial double bond character due to resonance, which results in the fact that the cleavage of the bond in haloarenes is harder than haloalkanes, and therefore haloarenes are less reactive towards nucleophilic substitution reaction. Difference in hybridization of carbon atom in CX bond. In haloalkane, the carbon atom attached to the halogen atom is sp3 hybridized, whereas in haloarene, the carbon atom attached to the halogen atom is sp2 hybridized, due to which the bond length in haloalkane is greater than in haloarene, and it is quite difficult to break a shorter bond than longer bond. Therefore, haloarenes are less reactive than haloalkanes. Instability of phenyl cation. Due to instability of phenyl cation, haloarenes are less reactive towards nucleophilic substitution reaction. Due to the repulsion, it is difficult for electron-rich nucleophile to come closer to electron-rich arenes. Replacement by hydroxyl group. When chlorobenzene is heated with aqueous solution of NaOH at 623 Kelvin and 300 atmospheric pressure, it gives sodium phenoxide, which on subsequent acidification gives phenol. The reactivity of aryl halides towards nucleophilic substitution is enhanced by the presence of powerful electron-withdrawing groups such as NO2 at ortho and para positions. The mechanism of these reactions is as follows. Orthonitrochlorobenzene reacts with hydroxide ion and forms orthonitrophenol. Paranitrochlorobenzene reacts with hydroxide ion and forms paranitrophenol. Metanitrochlorobenzene reacts with hydroxide ion and forms metanitrophenol. Electrophilic substitution reactions. Haloarenes will undergo electrophilic substitution reactions at ortho and para positions because electron density is maximum at ortho and para positions in resonating structures of halobenzene. For example, halogenation. When chlorobenzene solution is mixed with chlorine and then we add ferric chloride, which reacts to give 1,2-dichlorobenzene, which is a minor product, and 1,4-dichlorobenzene, which is a major product. Nitration. When chlorobenzene solution is mixed with nitric acid and then we add concentrated sulfuric acid, which reacts to give 1,chloro,2-nitrobenzene, which is a minor product, and 1,chloro,4-nitrobenzene, which is a major product. Sulfonation. When chlorobenzene solution is mixed with concentrated sulfuric acid, it reacts to give 2-chlorobenzene sulfonic acid, which is a minor product, and 4-chlorobenzene sulfonic acid, which is a major product. Friedel-Crafts reaction. When chlorobenzene solution is mixed with chloromethane and then we add some species of anhydrous aluminium chloride, it reacts to give 1-chloro,2-methylbenzene, which is a minor product, and 1-chloro,4-methylbenzene, which is a major product. When chlorobenzene solution is mixed with acetyl chloride and then we add some pieces of anhydrous aluminium chloride, it reacts to give 2-chloroacetophenone, which is a minor product, and 4-chloroacetophenone, which is a major product. Reaction with metals. Woods-Fittig reaction. This reaction is modification of Wood's reaction for the preparation of aromatic hydrocarbons. In a solution of bromobenzene, add some sodium, bromomethane in the presence of dry ether, which reacts to give toluene and sodium bromide. Fittig reaction. This reaction involves the treatment of haloarene with metallic sodium in the presence of dry ether to form diphenyl. Sodium is added in the chlorobenzene solution and then we add dry ether, which reacts to form diphenyl and sodium chloride. Polyhalogen compounds. Polyhalogen compounds are carbon compounds containing more than one halogen atom. Dichloromethane or methylene chloride. Due to high volatility and low inflammability, it is effectively used as a solvent, as a propellant, and as a metal cleaning and finishing solvent. The short-term effects of methylene chloride inhalation in humans consists mainly of nervous system effects, including decreased visual, auditory, and motor functions. Trichloromethane, chloroform. It is a colorless, sweetly fragranced liquid. It is used as a solvent for fats, waxes, rubber, resins, iodine, etc. It is used for the preparation of chloratone and chloropicrin. It is used in laboratory for the test of primary amines, iodides and bromides. It can be used as anesthetic, but due to harmful effects it is not used these days for this purpose. Long-term exposure to chloroform by inhalation in humans has resulted in effects on the liver, including hepatitis and jaundice, and central nervous system effects such as depression and irritability. Polyhalogen compounds. Triodomethane iodoform. It is a yellow solid having melting point 119 degrees Celsius. It is used as antiseptic because it liberates iodine, but due to unpleasant smell, it has been replaced by other medicines. Trichloromethane carbon tetrachloride. It is used in the manufacturing of refrigerants and aerosol propellants for the synthesis of chlorofluorocarbons. Carbon tetrachloride is also used in fire extinguishers and as a fumigant to kill insects in grain. Inhalation of carbon tetrachloride can cause liver cancer to humans. It can also damage nerve cells and leads to death. When tetrachloromethane is released into the air, it reaches to the atmosphere and causes depletion of ozone layer. Depletion of ozone layer results in exposure to ultraviolet rays, which leads to skin cancer, inflammatory reaction of the eye, and suppression of the immune system. Polyhalogen compounds. Freons. The chlorofluoro derivatives of methane and ethane are called freons. Some of the derivatives are CCl2F2, CCl3F. These derivatives are non-inflammable, colorless, non-toxic, low boiling liquids and stable up to 550 degrees Celsius. The most important and useful derivative is CCl2F2, which is commonly known as Freon 12. Freon 12 is prepared by treating carbon tetrachloride with antimony trifluoride in the presence of antimony pentachloride as a catalyst. In a tetrachloride solution, mix some antimony trifluoride in the presence of antimony pentachloride, and then Freon 12 is produced along with pieces of antimony trichloride. PP-dichloro-diphenyl trichloroethane. It is a white powder, insoluble in water, but soluble in oil. It is used as an insecticide. It creates pollution due to its extreme stability. It is non-biodegradable. Due to the solubility of DDT in fats or lipids, so once an animal ingests certain amount of DDT, it gets deposited and tends to stay, and it causes harmful effects to animals. Did you know? Freon was developed in the early 20th century to replace toxic gases such as ammonia, chloromethane, and sulfur dioxide used in early refrigerators. Chloroform is also used to extract and purify penicillin. Summary. Let us summarize what we have learnt. When an atom or a group of atoms is replaced by a nucleophile, the reaction is called nucleophilic substitution reaction. Solution of some organic compounds rotate the plane polarized light, and the compounds with this property are termed optically active. An object which is non-superimposable on its mirror image is said to be chiral. The property of being chiral is known as chirality. Achiral objects are those objects which are superimposable on their mirror images. Aryl halides are very less reactive towards nucleophilic substitution reaction because of resonance effect, difference in hybridization of carbon atom in CX bond, instability of phenyl cation. Polyhalogen compounds are carbon compounds containing more than one halogen atom. For example, dichloromethane, trichloromethane, triodomethane, tetrachloromethane, freons, and dichlorodiphenyl trichloroethane.